do, right? That's an example, what I just said. Go start learning about how staking works with Plutus. That's a wonderful course of study that would be time well spent. I want to honor time. We are at the official end of this session. But what I'm going to do now, I'm just going to keep rolling on this recording, and I'm going to lock some funds in this new version of this contract here that has the Faucet redeemer and takes a pub key hash this way. And then I'm going to demonstrate how to unlock funds from it so that we can use everything after this point in the recording as a lesson video that anybody who's not here right now can look at in the course. So I'm going to chop the video right here, and everything after this point will be posted on Canvas as kind of an assignment module so people can go try to unlock from this faucet. But if you want to stick around, do it live and ask questions. It's really fun to have company here. So if you got to run, see you soon. If you're still here, this next part should take, let's see if we can do it in 30 minutes. If I say 30, that probably means it'll take like 55, but yeah, that's how it is. So let's see how this goes. So I've got this thing. And one thing we didn't really talk about is like, okay, well, where do these values come from? I hope that you've already reviewed some of the other lessons and you know that the actual values of each of these fields is set at compile time. So we're going to take a quick look at the compiler. And it's this one, yep. And so here in this version of the compiler, notice that I'm importing the validator script that we were just looking at. Faucet validator script with PKH, that's this one. And it's a good idea to use this feature of Haskell if you have a long, some long name for an import. It's good to rename it like this. I didn't do that here just because I want things to be really explicit for everybody. So you can see everywhere I'm using Faucet validator script, using that validator, I'm using those Faucet params, and then even within the data object, these ones. Lucas, see you soon. So that's imported, and then it's used here. And if I was writing this code, more seriously, I would write like as FV or something, and I could replace this with FV. Okay. But for now, we'll just keep it this way. And I have set this up so that I can use the new access token and the new Faucet T gimbal that are on pre-production. And so let me just zip back over here for a second. Query tip, query UTXO, testnet magic 1, add address, wallet 1. All right, so look, this is this token right here, 748EE with name 5050. That's PPBL, etc. That's the access token, 748EE. And then the test gimbal FB45, that's this one right here. Okay. And 7467, that's a T gimbal right there. Make this a little bigger. And just let me know if I need to make the font even bigger here in my terminal. Okay, so what I want to do is lock some of these funds at the contract address. And I've got some notes that are in a README that are already part of the live repo as well. So you can get all of the notes I'm using right here if you have this PPBL course 2 repo. I'm in project 301 on the README. So I can build an address, just change testnet magic. And I've already done this part. In my output, I have a few different ways that I've played with this thing. This is the one we're using right now. And so this right here, this is going to be the address where I'm going to lock these tokens right now. So let me put that in the README. So we've got it. Contract address is this. You can use sender and sender key. I think I'm using wallet 1 and wallet 1 key today. Let me just make sure that's set up. Wallet 1. Yeah, I've got my keys set up. So I'm just going to change where it says sender here. I'm just going to change that to wallet 1 because I've already got that set up. Wallet 1. Okay. Then I'm going to go back and set these other variables here, and then I'm going to build this locking transaction. Let's just read through this for a second. I am still on Alonzo era. If I was on preview network right now, I would write Babbage era, but for pre-production and for mainnet, it's still Alonzo until the Vassal fork. I'm using 2 separate TX-ins because I've organized my wallet, as we'll look at in just a moment, so that my extra tokens are in UTXOs that have a limited amount of ADA in them. And I'm going to need another UTXO that's just pure ADA to make sure that fees are covered. Where am I sending things? Well, I'm going to send to the contract address just a minimum amount of ADA. And let me send more than 12,000 of the asset this time. Let me lock 300,000 of them. And then I've got this datum hash. Now, remember from a few minutes ago, this datum hash has to represent an integer, and it does. You can calculate the datum hash for any data by using this command on Cardano CLI, transaction hash script data. And there's a few different ways to pass data. One of them is just to write a primitive value like an integer, and you'll get the hash for that. So anybody who wants to unlock this, any funds from this faucet is going to need that datum hash. And again, just to put another point on this, we could say that this number is a secret, but if there was any real money behind this secret, you know how fast that secret would get out, right? And there's nothing really hiding it from anybody. Okay, so there it is, but you do need to know that number in order to unlock here. What are we locking? We're going to lock an asset. And oh god, yep.
So could that value be parameterized? Could that that number could that be like a single number for like each one, and that could be secret? Okay. Awesome.
Well, I mean, it still couldn't be secret, right? But I could say, yeah, I could say that, hey, Roberto's token is locked at value 1, 2, 3, 4, and A's is locked at, I don't know, what number would A choose? It's hard to know. But right, we could all use whatever number we want. But even more than values, instead of using script data value, here, let me show you this. Let's just drop this command into the terminal. Right, so script data value is one thing I can do, and there's a message down here. There's no schema, almost anything is supported, including top level strings and numbers, right? So that just gives us a lazy way to play around with things, and it's certainly simple, okay? 42, that makes sense. But right, the other thing you can use is you could use a whole file, right? So a whole JSON file, and for this, there is a strict schema. But following that, this is much more useful, right? To write a data object, and in that data object, we could put things like the policy ID and the token name and how many tokens can be unlocked. Not that those would by themselves stop anyone from doing anything else, but they would just identify the UTXO as belonging to this particular faucet, and then we could use those values in a validator. And so again, the reason I wanted to start writing this contract like this is I think that what's here so far provides anybody who wants to learn by doing with a really nice template to try to implement what I just described. Try to write a version of this contract that actually uses a more interesting datum, which we can then name an instance of, and then we can use that in our logic, right? What if the access token symbol was not coming from a parameter, but it was coming from a datum? You could do that, okay? And I absolutely recommend trying that if that's something you're interested in and you have the time to do it. Okay, so I want to be in the README. All right, so I got this datum hash. Yeah, it could be any number. I'm choosing to use that one. I have this contract address here. And let's bring this over to the terminal as well. And let's query it. Because one thing to notice here is that there's actually already a UTXO here at the contract address, just because I was playing around with it yesterday and I was trying to get this working on the front end. And we're one step away. Cremo's troubleshooting one thing we discovered this morning, but very soon we're going to be able to do this whole thing on the front end as well. The reason this is important is because we have a pretty unique case right here where my goal for this contract is to keep it so that there's always just one UTXO there. And so I don't want to just send a new UTXO here and ignore this one. I actually have to do something special right now. I have to take this as input as well. And then I'm going to relock it at the contract address. So we end up with just one UTXO. And that'll make more sense as we do it. But the first time you lock funds at one of these Faucet contracts, you won't have to worry about this step. And this is irrelevant to your unlocking exercise that you'll have a chance to do. But it is something that I have to deal with right now. So I'm going to grab this TX hash right here. And I'm going to switch back to my editor in just a second. I'm just pasting this first, index 3. Okay. So back over here, I need to use this contract TXIN as another one of my TXINs. All right, cool. Now I have to recognize that this TXIN is from a contract address. So I'm actually going to have to unlock it in the very same way that you're going to have to when you go and try to pull some funds from this thing. Okay, so the answers to this exercise, I'm about to show them to you right here, embedded in a bigger transaction. So let's think about this. When I build a transaction where I'm trying to unlock from a contract, there's a few other things I have to add. And maybe I haven't memorized those yet. And so I'm going to switch back over to my terminal. And I'm going to write Cardano CLI transaction build just to remember. Let's see. TX in. Oh, I'm going to need a script file. Yeah. I'm going to need some datum. I'm going to need a redeemer. All right, let's get all of those things. All right, so over to my transaction build, TX in script file, TX in datum, value is enough, right? I hash it on the output. The output gets the hashed version of the datum. but the input, I can just write the number. All right, that one's easy. 168. Okay. And then I'm going to need a redeemer. And in this case, I'm going to use the file. And I'll show you what that file looks like in just a moment. And if I have the script, the datum, and the redeemer, that should be sufficient. All right, back over to where I'm drafting this transaction. Okay, I'm going to need 2 TX ins from my wallet, actually. All right, and I'm looking once again at my UTXOs here. So I have a UTXO that has 450,000 test gimbal tokens in it. That's going to be this one. Okay, I'm sorry. I know I'm not sharing my whole screen right now, but I'm just looking at the CLI to get that UTXO. And then I need another one that has just a bunch of ADA in it. 10 should be sufficient. So I have another UTXO here that has sufficient ADA to cover all the fees. Any questions so far? All right.
Yeah, just a quick one. This has always somewhat perplexed me. I remember way back in incentivized testnet days, it was a thing, and then TTL basically, and then it ceased to be a thing, and then apparently it then became a thing. So I'm looking at, the building section. I don't see any TTL calculations happening here. I'm assuming that either it's not a thing anymore on testnet or mainnet, or maybe I don't know. Yeah.
I'm really looking forward to, like, in the year 2035 doing some cast.live episodes where we talk about remember when, but we can already do it here. See, these are once
Exactly.
again, we used to have to walk through the snow barefoot for 17 miles just to learn Plutus stories, right? But no, they're so
Back
just
in my day.
back in my day, we used a function called build raw, and you actually had to write a whole transaction just to calculate a fee, and then you had to figure out with a calculator. You actually had to do it by hand. You had to figure out what the fee was going to be and what the output was going to be, and TTL and all this other stuff. And thank goodness that software gets more abstract over time, right? So that, yeah, there's a build raw still exists for anybody who wants to beat themselves up, go play with it. But luckily there's a new function called build instead of build raw that does take care of a bunch of stuff for us. It was, it's actually kind of sad that this was one of my most exciting days of the last year, but I was very excited when I found out about change address just being this thing that we could now use. You used to have to calculate down to the precise Lovelace how many tokens were going to each output, and then you always had to make sure to send the rest back to some address. And that's all just taken care of us for us now. Thank goodness. That's amazing. Now we still have to do the arithmetic with tokens other than Lovelace. So there's still some of that here, and maybe a future version of Cardano CLI will have a function that where change address can just take care of any number of tokens, not just Lovelace. But still, this is a pretty good step here. And the fact that we don't have to calculate the fee ourselves is absolutely a huge time saver. Okay, but enough reminiscing. Let's get this thing to work. What I got to do next, let's see, I need the path to the script file. And I typically wouldn't need this part, right? Once again, to reiterate, in an initial locking transaction, this step is usually not going to be part of things, but I'm actually doing an unlocking transaction and a locking transaction at the very same time. let me just grab, I could have grabbed these from here, whatever. Let's just paste those here because they've already got the variables. So I'm going to want a file called redeemer.json. Again, the name of this is arbitrary. You could call it anything. The Plutus script file that I just compiled, I'm going to want path to that. Let's get that. It was this one. Uh-oh. My mouse just went here. I gotta stop sharing for a second. Zoom just gave me a headache. Let's try that again. Okay. Copy the path to this one and drop it in here. All right, so I got the path there. The asset that I'm locking, I'm just going to copy and paste from my UTXO view. So I'm just grabbing that from off screen. Here it is, right? Policy ID dot token name. This is the T gimbal. Plutus script file is taken care of. Let's make that Redeemer file. In the interest of time, I'm not gonna talk through all the details of this Redeemer file right now. I'm just gonna show it to you for now, but it looks like this. So it's JSON format, it's a JSON file. We have a constructor. This is going to be a valuable tool when we start to understand that redeemers can specify actions, but for the moment, we can ignore it. And our redeemer has one field. The field for our redeemer is a string, and we use bytes. In general, we're going to use byte string, okay? Now, what's nice about pub key hashes is that they're already in this format. But if you had a string like hello world, you would have to convert it to a hex string first in order to be able to use it in a redeemer like this. But I've probably gone deeper than I wanted to already, okay? When you try to unlock from this contract, you can just copy this as a template. I will provide it in the notes, and you'll just replace my pub key hash with your pub key hash, the one that you're trying to withdraw funds to, okay? I'm just going to copy the path to this file. I have it in the transactions folder. Let's go to that folder because then I could just use that file name. Transactions. So there's a bunch of other drafts here, but the Redeemer is in this folder, and that is the one I want to be using. So that's great. Cool. Let me just double check that that is the one. I'm using pre-production wallet 1. Yeah, good. Okay. So I got the Redeemer. Okay. Now I'm going to send to the contract address. I want to place 300,000 ADA there. I'm using a TX in that has 452,000 ADA there. That was the output of the last time I tested this thing. And so that means that I can withdraw to wallet 1 the rest. And what's the rest mean? Well, I've got wallet 1 and I've got contract address. The contract has 9,000 test gimbals in it. The UTXO I'm using has 452,000. So 461 total. If I'm putting 300,000 at the contract, then I should be getting 161,000 back to my wallet address. Now let's go back to the validator for just a moment here. This is precisely the case why I didn't use an equal sign right here. I said that the receiver has to get at least the amount of tokens specified in the withdrawal amount, which is, if we look at the compiler, 3,000. Okay. But the reason I wrote greater than or equal to sign is for cases like this, where I want to be cleaning up my contract or managing it, right? This gives me the ability to say, okay, well, if I want to consolidate UTXOs, I can still do that. There is a guard down here that doesn't allow just anybody to go and take as much as they want out of a faucet, right? Because what we do, and this is another one of those cases where all of this logic should probably be written as a helper function. But for now, you can see the faucet contract has to get the number of tokens that it had in the input, take away the withdrawal amount, and that amount can't exceed the amount that we're sending back. And so that allows us, that's just the guard against somebody taking, 10,000 just because they hold the access token. Kind of long-winded explanation about why we're able to get away with this right here. Okay, and then we'll send the change back to the wallet. Do I have a protocol file called preprod yet? Yeah, I do. I have, now that there are all these different networks, I no longer am naming my protocol files just protocol.json because I would lose track. So I've been just naming each of the different protocol params files by what network they represent to save future time. All right, this thing should work. Just kidding. I already know it's not going to work, but does anybody know why? Let's see. I'm going to show you something here. All right, all I'm doing is I'm pasting all those variables right there. So now I can use them when I build this transaction. And did anybody notice the bit that I ignored here? I pulled in a bunch of gimbals. I pulled in enough ADA to pay for fees. But there's another thing that this contract expects that I have not yet accounted for. And we're about to see a Plutus error message right here. Let's see. Oh, that's a boring error message. Yeah, I forgot to set collateral. Okay. Good. Let's do that. We'll get to the better error in just a second. Right, because I am unlocking here, I need to have collateral specified. Anytime you want to unlock from a contract, you need a line that looks like this. And I forgot to add that TX in collateral. Let's just do that here. And I recommend just having like a UTXO that you can always be using as collateral. I have one with 5 ADA in it that I'm just never going to actually spend. And so let's grab that. And drop that. All right, let's try this again. But now hopefully this time we'll get a more interesting error. Collateral. Let's try it. Ready? Okay. Now I also, speaking of the old days of Plutus, when we started building Plutus transactions, we were not able to actually see the messages that we wrote in our validator code. It would just say, hey, that thing failed, and it wouldn't tell us why. But this was another exciting day when the script debugging logs were added to transaction build. And of course, there's this other thing that I did not account for. The input needs a PPBL summer 2022 token. So this is an easy problem to solve. All I have to do is grab one of these UTXOs and just add one more TX in to my transaction. So I'll do this all in the command line and talk it through as we go. I'm going to call this the auth token TX in. I'm going to set it to the value that's highlighted on my screen. Okay, bring that over here. And then I'm just going to add one more TX in that has that variable name. So when I paste this build again, you can see what I just added here is another TX in. This one with the hash I just specified. And of course, it has that authentication token. All right, let's see if this one validates.
Does that token need to be balanced in the output?
It does. Look, I got another error. Good job. So let's add that. All right, so I can add over here. Now I could just include that in one of these other TX outs to myself, but to keep my wallet organized, my preference is to make them separate. So I'm going to send it back to my address again, just to ADA again, and then this time I'll add one auth. So, well, you know what, this one, instead of writing a variable for this, I'm just going to copy that asset string. All right. All this use of variables that I'm doing right here is just a preference. You can also always just write values here, right? All right. So Plutus once again gave us another error. In this case, the PPBL summer 2022 token must return to sender. And right, so yeah, it was placed in the input, but of course it has to be sent back to the sender as well. Let's do it. I'm actually surprised that we didn't get an unbalanced transaction error there. I think that's because of the order of my inputs and outputs. It looked and tried to validate first because it got to this validation line, all this stuff, before it got down to like looking at the actual outputs. But I might be wrong about that. Oops. All right, let's try this. There we go. All right, it's expensive. That's what, 5 or 6 times the fee of the lowest cost transaction that we could write. But still, for less than an ADA, we're doing a meaningful interaction. And this is going to be one of the huge benefits of Plutus V2. I'm really excited to see what this fee is when we're using reference scripts instead. And when we're able to look at, for example, an auth token input without consuming it and sending it back out. All of those changes after the Vassal hard fork are A, going to make our lives a little bit easier, and B, they're going to reduce transaction costs. But this looks good. I should be
In that case,
Yep.
well, just a quick one here. The additional, yeah, I suppose it's curious. The additional cost that I'm assuming would be incurred by maybe it's not really an increase in the data size, because if you've optimized the transaction itself, with things like reference inputs, then from a data standpoint, it's cheaper. But from a computation standpoint, from what I understand, the computation also factors into the fee. So like it kind of offsets it. Yeah. But then it might be a bit more expensive. So I don't know. I'm curious about that.
We're still going to pay for computation, but alone, just not even including this script file is going to save us some lovelies, right? So you're exactly right. The computation still has to happen, but at least we're not sending this data right here over the network every time we interact with the smart contract. Sign it. and I can submit it. And it's such a joy how blazing fast pre-production is. You know, another thing just to remind ourselves every time here, the only reason we're able to use this network is because somebody's running it. You know, and I think a lot of nodes are being run by IOHK right now, but there's also some people who are choosing to run a pre-production node as a service to the community, and they all deserve a shout out. All right, so let's query those addresses again. And sure enough, we see a nice round 300,000 test gimbals here. We see the other 161,000 test gimbals in a single UTXO with just 2 ADA in it. We also see that this transaction hash here has an index of 1. There were 3 other outputs from this transaction. And you can see that all of them have precisely the same transaction hash. There's the one that sent the change back to me, just ADA. Now I used one of these UTXOs that had 10 ADA in it. Now I have 9.3 or so. I've got these 2 and those tokens, these 2 ADA and my auth token. And then I left 2 ADA at the contract address. So what questions do you have now?
Is there an IDE which has like a REPL where, like, as you're doing it, you're able to in real time see the errors, or is that
For transaction
not a
building?
thing? Yeah.
That would be really interesting. Well, it would need to, I'm not aware of one, and it would need to be live querying the on-chain data as you're writing the transaction, right? So if I paste a transaction hash into VS Code, it would have to automatically find that transaction hash and know what value is stored in it, for example. I mean, that would be a cool tool. That'd be interesting.
Yeah, cool.
I wouldn't be surprised if Kyle and the Cardano Sharp team have something to say about that. And he would, I don't want to show him the video from yesterday because he'd be mad to know that we weren't just using his tools to create multi-sig transactions, but we'll get him over here to talk about those soon. All right, so people need to know that the datum hash represents the integer 1618. And people need to know that 3,000 test gimbals can be withdrawn at a time. But of course, the last thing people need to know is they need to have a access token in the first place. So the last thing I'm going to do today is send a bunch of these on pre-prod. Okay. So now I have to scroll back up through the chat and just copy all of these over here. This part, I think I can still do this in 15 minutes and hit that goal of 55 minutes. This is going to take me just a few minutes to do this, and this won't be as interesting as the rest. So,
hey James, just confirming again. Unlocking also needs the script file, right?
That is correct. So I have to share the script file with you. Thanks for saying that. That's right. Thanks, Roberto. See you soon. And if anybody's dropping off and you need one of these tokens, just look for it at the address that you shared and it's coming your way. need a script to copy and paste from a Zoom chat. Anybody got one of those? One, I'm seeing that you shared a NAMI address. That will not yet work for this. So I'm going to put that on hold. There's a few reasons it won't work, but the first and foremost is that NAMI is running on a different network than we're running this experiment on right here.
Yeah, I need to have it a production mode, pre-production. Yeah.
Yeah. You
I wanna
can
play with it.
you can open a pre-production account in Eternal, and I'll be happy to send you one of these.
Okay.
And then you're just gonna have to wait until Cremo and I just troubleshoot this last issue. We're trying to make sure we know how to write a good redeemer in that new library. Nicholas,
Got
thanks. Yep, got it. All right.
Thanks.
If anybody's catching up with this video later, I will need your address as well in order to share an access token with you. So just, you can either DM me on Discord or find some other way to reach out, but I'll make sure to share that information. Okay, so what do I want to do here?
Quick question here. It would be possible to say, create a multisig of all the folks doing PPBL summer 2022, and that multisig basically be like a one of, I don't know, 15, right? Then that would, yeah, cool.
These are the kinds of ideas that it's so awesome when people are having them, and run with them. This is how we tinker, right? And I would love to see somebody take the lead on managing some, silly multi-sig address, and so we can run some experiments together. That'd be really, really fabulous. All right, so I got a bunch of receivers here, but other than that, this is not going to be a complicated transaction. So let me grab, I'll still use this as boilerplate, and then we'll just get rid of the unnecessary stuff. All right. So I am going to need I'm going to need 2 TXNs this time. One that has a bunch of those auth tokens, another for fees. I don't need scripts or contracts or anything like that. Data hashes. I'm going to make a bunch. Actually, this is a nice template right here. This is the template I can use. This is what everybody needs. So every receiver is going to get 2 ADA and 1 access token. One, two, three, four, 5. And I'm doing this right now. Remember, like when you see me do something like change the numbers 1, 2, 3, 5, and you're like, okay, that looks robotic. That's exactly right. I find that by building transactions this way, it gives me an intuition for what needs to be automated. And we're using like bash and transaction building as our pseudocode before we start building real orchestrators. Sebastian.
Thanks. In an unpredictable future, how do you establish the amount of collateral in the future?
Very good.
My
Right. There's an informal but kind of lazy and insufficient answer right now, and the answer is 5 is usually enough. But obviously, we want a better answer than that moving forward. And collateral is another thing that's changing. Okay, so with the Babbage era changes after the Vassal fork, people just won't have to think as much about their collateral the way it is right now. If I put 100 ADA up for collateral and I build a bad transaction, I lose that entire collateral. Post fork, what's going to happen is whatever amount of Lovelace might have been in my collateral UTXO. Only the appropriate amount of collateral will be deducted and the rest of the funds in that UTXO will still be returned to me. That's a really nice change, right? So it allows us to not have to worry about always making sure that we have a UTXO that doesn't have so much ADA that we would be pissed off about losing it. All right. 2 TX ins, 5 TX outs, and some change. Everything else here should go pretty easily. I just need to drop these receiver addresses in. And then I need 2 TX ins. For one of them, I need the one with all of my access tokens in it. So that's here at index 16. For my other one, I'm just going to use, I'll use this one that has this 9.3 or so ADA in it from before. Oh no, that won't be enough because I'm trying to send 2 ADA to everybody. Never mind. TX into, let me just use this big one right here. So those are my ins. I've got the 5 receivers out, and that should be sufficient to write a pretty simple transaction. Yeah. Oh, it's not balanced. Yeah, I got to send the rest back to myself, of course. All right. So wallet 1, right? So even though change address takes care of the extra Lovelace, it doesn't take care of extra native assets. So I'm sending 5 of these tokens away from a UTXO that has 135. That means I got to send 130 back to myself. And we can see that the error does that math for me. Let me try this again. That works. All right. So even this one, you know, what is that? 0.03 ADA more than maybe the minimum fee, because there's multiple outputs here.
Sorry, man, in what line do you establish the return of the tokens? The rest
Oh,
of
the return right here, this one.
okay. Okay.
All right.
Thanks,
The
man.
wallet 1 represents
Okay.
the
Of
wallet
course.
I'm using, yeah, and the rest of these. All right. And I can use the same sign and submit as usual. What did I say? Oh, I have the wrong file. Sign key, invalid argument 1.
I think you have the wrong TX body.
Oh, TX. No, I had the wrong name. Yeah, I made my newest transaction had an out file called TX lock. And then I was just lazily grabbing one that had a different file name for the draft. Here we go. This out file. I should have been more precise about that, but I'm not saving this transaction for anything. All right. So people should, in just a moment, have those tokens ready to go. My next step is to share with you. I will share the already compiled Plutus script file. It's just this bit of data right here. It's a small file. It's longer than the other ones, but like that's still not that much data, right? You'll need this file. You could try to compile it on your own for a challenge, but of course, like I said, I'm going to share this. You'll need the address, and you'll need the token that's now in your wallet. And you'll need to know that the datum value is 1618. but we should be good to go after that. As always, my advice when you start trying to build this transaction is once you get it working, before you sign and submit it, try to change a few things just to screw it up, right? Just so you can see the different error messages. And this might happen automatically if you don't see it the first time, but even after you get that transaction build working, try to make an unbalanced transaction. Try to make a transaction that has some datum value other than the value where these funds are locked, right? And yeah, it should be fun. Oh, you know what? There's and I didn't, you know what, I probably didn't say this sufficiently. So this is another thing people are going to run into. Should have thought about this. And it would have been great to have a little bit more time here, but in the unlocking transaction, in order to validate the contract, you are going to have to send the additional test gimbals back to the contract address. So you do still have to manage this part. And I suppose that anybody who you know wanted to play a little prank on anybody could change that datum hash. You could. Okay, so try to make sure to hash that datum. I'm gonna have to write that in the docs as well, because when we relock this UTXO here on an unlocking transaction, we have to make sure to relock it with that datum hash. This is a non-issue when we're using only a front end, because we can orchestrate the front end to do that for us, to always use that same datum. But in this case, we have to rely on each other to keep that there. And you know what? If somebody forgets that step, then there's just going to be some lost test gimbals on the pre-production network. But that too would be a worthwhile learning experience. Nice, Nelson got the token. Good, yeah. So if you check your wallet now, you should see that. Everybody should have the same transaction hash. And there we go. 15 seconds to spare. Cool. Thanks for staying late. Anybody who stuck around the whole time. If you're watching this later, of course, I'm sure you'll have questions, so be in touch. And we'll see what happens next. Thanks, everybody.
Thank you.
Anybody got last questions before we sign off?
Thanks, man.
My
No,
pleasure.
thanks.
My
Have a good
pleasure.
one.
Thanks for being here, Nicholas. Thank you. All right. Yeah, Nelson, I'm so glad we're finally here, man. Feels good to finally be talking Plutus and documentation with you. All right. Cheers, everybody. See you next week. And indeed, Mix, good luck, everybody. See you soon.
See you.